Hello, welcome back to Python and welcome back to Pandas and welcome back to Numpy. So why am I telling you welcome back to Numpy? That's because today's topic is combining Numpy arrays, two-dimensional arrays to be more specific, and our data frames from Pandas. And yeah, that's kinda cool because Pandas and NumPy synergize as well, and I already promised in my first video that we are using NumPy in this series. So let's import Pandas, let's import NumPy as NP. And I hope you remember certain things about NumPy, but I will make a quick reminder. First of all, let's create our randy equals NP. Let's create a random NumPy array which is two-dimensional, random point randint from range 1 to 111. This is we are creating a two-dimensional array containing integers from 0 to 110. And yeah, as a shape, which is the next argument, we have our starting range, the ending range, then our shape, and yeah, our shape is 4 rows, 4 columns. First the rows, then the columns. And yeah, now if we're printing it, we print our random NumPy array. Here we go. And what we want to do now, we want to create a data frame based on our randomly created NumPy array. Pandy the cute panda equals pd point data frame, and we simply have to use as the input just the NumPy array we created, like this. And yeah, we should print it. Sorry if my voice sounds strange, I'm a little bit sick still. Yes, now we have our NumPy array, our Panda data frame. We have our column indexes, our row indexes, and we can even rename our row indexes like we know it from before. If we are typing index, not like that, index equals A, B, C, double D. Here we go. And yes, this is not everything we can do when we are using NumPy array. The fun part begins when we are kind of calculating with statistics and creating bigger arrays and bigger data frames, like 4000 rows. Let's just do that. 4000 rows. Let's delete our index because it would raise an exception. We can't use index 4 with 4000 rows. We also want 4000 elements in the list when we are declaring the index, so we are just skipping that. And yeah, we don't want to print this data frame. Why don't we print it? We want to mess up our console. So maybe you remember from the first video of the Panda series, I described the function describe. Man, this is a joke, and that lately I described the function describe, describing how describe works. Look in the description. Okay, enough of that. PD data frame, no. Print pandy, the cute pandy point describe. And now what we get is interesting. On the left side, where we usually have our indexes of the row, we have count, we have mean, std we can skip because it simply means the standard deviation, but we are not diving that deep, so we will skip that. The minimum value, the maximum value, and yes, he's showing, for example, the minimum values of every column, which is always 0 because we are having 4000 rows, and yeah, these are plenty of options to get to the minimum of the range, and yes, we have plenty of options to get to the maximum of the range. That's why he's always hitting 110 every time, and 75% is nearly mostly the same. 44. Mean is kind of interesting because it is average, so he's, for example, counting. Count is 4000, obviously, because we have 4000 rows. Every column has 4000 elements, and yeah, because we have 4000 elements, mean is pretty easy to calculate because we are adding every number and yeah, dividing them by 4000, getting 55. Yeah, and the lower 25% are 28 or lower, 50% are 54 or lower, and so on. Man, it's hard to talk at the moment because my voice is cracking up. But yeah, I have to keep it up. And yes, we can even call the functions by every function. We can call the min, getting the minimum, which will always be 0. The max, getting the max, which will... What did I do now? Because he's splitting the max of the rows, but we want the max of the columns. Ah, okay. Here we go. Yeah, now we have the max of the columns again. And because we have plenty of options, he will always hit the maximum. If we're decreasing it to 40, you should get a little bit more diversity. Here we go. Only one column got the highest possible value. The other ones are, yeah, it's near of 110, but not reaching it. And yeah, the same goes for mean. And so on. And because Numpy randint is much more, yeah, you can't only create random integers, random int arrays. You can even calculate at which probability which number can be created, and this can be kind of interesting combined with the describe function or the function of DataFrame, because you have many options to, yeah, calculate the output. Now, what was not in the describe function was sum, which is also quite easy to understand because it's just the sum. Man, I'm perfect in explaining now. What I wanted to say, it's the sum of every integer. If we say again 4000, but now getting minus 100, can be more interesting and diverse because we are mostly hitting positive numbers. Let's speed more, but now if we are, yeah, using very low negative numbers, and the sum of 109 and 111 is nearing to 0, so we are even sometimes getting negative numbers while running it. But yeah, that's the sum. It's just of all the rows, the numbers of all the rows added. We have also skew. By the way, I'm not showing every function, I'm just, yeah, kind of giving an overview. There are much more functions, which is kinda, yeah, between yeah, usually between 1 and -1. So skew kind of returns how symmetric our frame is, like if we are where's the code? Skew, let's type in skew, and yeah, it's like of the symmetry between expected output. Yeah, there's a difference between the accepted output and the real output, because yeah, the integers are randomly, and if the number gets higher, the skew should be getting lower. Does it, or am I talking nonsense? I guess I'm talking nonsense. Oh no, I'm not talking nonsense because I wanted to. Yeah, I'm not talking nonsense. Okay, I'm kind of relieved, because I don't want to explain bullshit. Yeah, but that's everything about, that's a little overview of the functions you can do with your data frame you created with a Numpy array, a two-dimensional Numpy array. You can also create a series with one-dimensional Numpy array. And yes, that's everything for this part. I hope you kind of enjoyed the video. See you in the next video. I wish you a wonderful evening, dinner time, night time, breakfast time, whatever time it is. See you and bye bye.